Hi everybody. Today we're going to take a look at how to authenticate against the weather API and make actual API requests to get data in which we can interact with. Last time we looked at how to read through some of the documentation, and today we'll look at making actual API requests to the current.json endpoint, and then looking at how we can load that into a database. So on the left-hand side of the screen, there's three libraries that we're using. The first is the request module. That's a framework or library rather that allows you to make HTTP requests in Python. It's quite a popular framework. The next library we're using is .env, and what that allows you to do is store application secrets in environment files rather than hard coding them inside of your scripts, and we'll talk about that in a minute. And then we're also using SQL Alchemy to define database models in Python code in which will help us load the data into the database. So let's start by inspecting the .env file. So you'll see on my screen that we have a .env file. When we open this, you'll see that we have two secrets defined. The first is the weather API key that I have, which will be rotated after I release this video, as well as the database URL. Now the whole point of doing this is so that we keep these secrets outside of the code. So you could imagine that if you're using version control, so for example, you're using Git, it's not a good idea to have these secrets lingering throughout the code. So the way you can get around this is by storing them in your environment. And in this case, Python has a library called .env, which has an interface called load.env, which takes a path to this file. And once you load that file, you then can use the os.getenv interface to then load those secrets. So this is a convenient way. It's not the only way, but this is a convenient way to keep those secrets out of your code and keep them well secret. Now going a little further through the code, you'll see that we've defined the base URL, which is the base URL defined out in the docs, right? The weatherapi.com/v1, as well as this current.json endpoint. And that's the data that we want. We want the current weather data. Now if we scroll a little further through this script, you'll see that we make the actual GET request on line 34. So request.get, and you can see that I've joined the base URL and the current weather endpoint and made a GET request with it. But you'll also see that we're passing query parameters. So if you recall from the other video, there were two required parameters that we have to pass to this API to authenticate or to make a successful request. The first is to authenticate using your API key. And the second is passing this queue parameter, which if you remember, has multiple different elements that it can contain. And in this case, we're just going to pass the name of the city in which we want the weather data for. Now, because we're calling the current.json endpoint, we're going to take the response text that we get back, and we're going to use the JSON module to load it into the JSON structure. So to take a look at what this data looks like, let's drop a trace. And let's run this script. So you can see we stopped the execution of the script on line 39, and we'll use the pprint module, or pretty print, which allows you to print data structures in a more readable way. And you can see when we do this that we have this JSON structure where we have the current data, which corresponds to the data elements that we read in the documentation. So we have things like the temperature, we have things like the UV index, things like the gust speed and everything. And also remember we had this location object, right, that the documentation told us about. So this is a data structure that provides information about the location in which you requested the data from. So it'll give you things like the country or the longitude, latitude, the local time in which you requested the data for. So by setting a trace like this, we're able to inspect the data that we're getting back, and we can make decisions on how we want to handle this information. So recall that we're using SQL Alchemy. So what we've done is we defined a current weather SQL Alchemy model. And on the right-hand side of the screen, if we take a look at this, you'll see that it's a simple class that defines a couple of columns. So to make this example simple, I'm just collecting the location name, when it was last updated, temperature, the wind speed, and the humidity. So what we're doing on the left-hand side in the script is we're basically taking that information from that request, and then we're using that to instantiate the SQL Alchemy model. Now this obviously isn't a tutorial on SQL Alchemy, but let's say you're using a CSV file to store your data, or you're using another ORM. Well, it's the same idea. You could just take the information that you want, manipulate it in the way that you need, and then you can store it or persist it wherever or however you need to. So just to continue down our script, what we're doing is we're taking that entry or this SQL Alchemy model, we're adding it to our database session, and then we're making a commit to the database. So if we take a look at the database, let's run this one more time. And what we should see is we should see an entry inside of the database table. Now recall, you don't necessarily have to use a database. I mean, you can store this in a CSV file. You can store this, however you see fit. But if you're using a database, in this case, we're using a SQLite database, it can make things easier. But you can see that when we make that API request, we've taken that information that we wanted, and now we have an entry inside of this table. So this is just an easy way to implement just a simple way to make a request. In the next video, what we'll do is we'll take a look at how we could perhaps make requests to multiple cities rather than just hard coding Toronto, and how we can handle things like API errors, or how we could perhaps schedule API requests to be made because perhaps your application needs to be updated with the most current data on a regular basis. Well, obviously the way we've done it here is quite a manual process. So we'll take a look at how we can automate that and have it scheduled in Linux. That's it for today, guys. Thanks.